The sources provided, while rich in detail regarding the potential Tesla-Intel chip partnership, do not contain 1,000 words of content. To ensure strict adherence to the constraint that the response must be directly supported by the provided material and comprehensively cited, I will generate the most comprehensive script possible based on the available text, which will result in a script shorter than the requested 1,000-word target. Here is the video script. The potential Tesla-Intel chip partnership is demanding attention across the technology industry, primarily because it could deliver AI chips at just 10% of Nvidia's manufacturing cost. This claim represents a significant development in AI infrastructure that enterprise technology leaders cannot afford to ignore. This discussion publicly surfaced on November 6, 2025, when Tesla CEO Elon Musk stated at the company's annual shareholder meeting that Tesla is considering working with Intel to produce its fifth-generation AI chips. This statement signals a major strategic shift in how AI computing hardware might be manufactured and distributed. According to a Reuters report, Musk told shareholders that they might do something with Intel, although he clarified that no deal had been signed, noting it was probably worth having discussions with Intel. The market viewed this potential collaboration seriously, as evidenced by Intel shares rising 4% in after-hours trading following the statement. The context behind this potential partnership is critical for both companies. Tesla is currently designing its AI-5 chip, which is intended to power its autonomous driving systems. The company is currently utilizing its fourth-generation chip. However, Tesla has identified a significant supply constraint that cannot be fully addressed by traditional partnerships with existing suppliers, specifically Taiwan's TSMC and South Korea's Samsung. Musk explained during the shareholder meeting that even extrapolating the best-case scenario for chip production from their current suppliers, the output is still not enough. This supply gap has prompted Tesla to consider building what Musk refers to as a Terafab. This would be a massive chip fabrication facility designed to be capable of producing at least 100,000 wafer starts per month. Musk emphasized the necessity of this project, saying, "I can't see any other way to get to the volume of chips that we're really looking for. So I think we're probably going to have to build a gigantic chip fab. It's like a giga, but way bigger." The development of such a terafab would represent a major expansion of domestic chip manufacturing capacity. For Intel, this potential collaboration offers a vital opportunity. Intel has been significantly lagging behind Nvidia in the race for AI chips and urgently needs external customers for its newest manufacturing technology. Adding to the strategic weight of this opportunity, the U.S. government recently acquired a 10% stake in Intel, underscoring the strategic importance of maintaining domestic chip manufacturing capabilities within the U.S. The technical specifications outlined by Musk, should they materialize, could dramatically reshape the economics of enterprise AI. Musk stated that Tesla's AI-5 chip would not only cost just 10% as much to manufacture as Nvidia's flagship Blackwell chip, but would also consume approximately one-third of the power used by the Blackwell chip. These efficiency and cost projections, if realized, could fundamentally alter the economics of AI deployment. Musk noted that the AI-5 chip would be inexpensive, highly power-efficient, and optimized specifically for Tesla's proprietary software. Regarding the production timeline, Tesla has provided a roadmap for enterprise planning. The company expects a small number of i5 units to be produced in 2026, with high-volume production potentially achievable in 2027. Looking ahead, the possibility of a Tesla-Intel chip partnership generates several key strategic considerations for enterprise decision-makers. First is supply chain resilience. This pivot toward domestic chip manufacturing addresses concerns about the concentration of the chip supply chain in Asia. Enterprise leaders managing technology risk should examine how these shifts in chip manufacturing geography might affect their vendor relationships and supply chains. Second are cost structure changes. If Tesla successfully achieves its stated cost targets, the competitive landscape for AI chips is likely to shift dramatically. Organizations should develop contingency plans to account for potential price pressure on current suppliers and evaluate the viability of alternative chip architectures. Third is technology sovereignty. The U.S. government's stake in Intel and its support for domestic chip manufacturing reflect broader geopolitical considerations. Enterprise leaders, particularly those in regulated industries or those handling sensitive data, should assess how these trends might impact their technology sources. Finally, the innovation pace is accelerating. Tesla's aggressive timeline for rolling out multiple generations of chips suggests an accelerating pace of AI hardware innovation. Technology leaders must factor this into their architecture decisions and refresh cycles, being cautious about committing prematurely to current generation technology. Musk's statements are set against the backdrop of ongoing U.S.-China technology competition. For example, export restrictions have already impacted Nvidia's business in China, reportedly causing its market share there to drop from 95% to near zero. While Intel has declined to comment on Musk's remarks, and no formal agreement has been announced, the public nature of the statements and the strong reaction from the market strongly suggest that substantive discussions may soon be underway. The AI chip landscape is entering a period of flux, and organizations should maintain flexibility in their infrastructure strategies to monitor how partnerships like Tesla-Intel might fundamentally reshape the competitive dynamics of AI hardware manufacturing. The decisions made today regarding chip manufacturing partnerships could ultimately determine which organizations gain access to cost-effective, high-performance AI infrastructure in the near future.